It's getting faster. Notice the RPMs start to pick up speed. Just picked up. Just went faster. Picking up speed. There goes what? 2, 4, 5. 4.8 watts per one of those lights. These are 3. I believe these are... Gonna say 65 watts each. We are pulling a fluctuating amperage and we're putting into the Dremel, this is in wattage, 135 watts. And we'll click it over to amps. 1.1 amps is going into the Dremel. Amps. 0.9 amps. Woo! NASCAR. Hello, everybody. This is Roy. I'm back again. Hello, my fellow YouTubers. So who do we have out there? Adam. Adam, thumbs up. Who else we got watching? Any shouts out? All right, well, we can move on here. I got some interesting stuff. Hassan, what's up, Hassan? What's up, man? I love your comments. I love your 1, 2, and 3 joke, especially the knife and the other one. I mean, unbelievable. How we can just take science and mix it up. What's up, Scott? You got Scott from Upper State, New York. Hassan's from Canada. Hello, Canada. We got Adam in the house. Yes, I did see that link, and I read your link and went on there. Good stuff, man. Good stuff. Good stuff. So let's start this whole conversation with I will share it. Oh, actually, Adam, you go ahead. You go ahead and Adam, and just you got Alsan's connection there. He'll share it to you. So let's talk about many phases, okay? So what is a phase? What is a phase? Let's put it out there. Let's just broadly open up dialogue for all of us to talk about. What is electrical phase? Any comments? All right, well, I don't see anything popping up. Hopefully the internet's not bogging out. But I'll start off by saying a phase is a position in its strength. Like the phase is the upper part of the... All right, so you have to look at it this way. You have to look at the phase as there's a pulse, and then there's a peak on the amplitude of that pulse, and that piece becomes angular, okay? Based on its velocity, based on its induction. So let's just go there. There's your phase, okay? Of a wave. Yeah, it is a phase of a wave. So there's your phase of a wave. And if we could draw it, I guess it would just be like like this. Like each one of these lights would be a top and then a bottom. And then it'd be a top and a bottom and vice versa, okay? So with bringing a phase in there, so what do we do with a second phase? What do we do with, what did Tesla, Mr. Tesla, what did he do with the three-phase? Well, he's most popular for his three-phase invention, his three-phase motor. It's a great turning motor. Has a lot of torque to it also. In fact, I read that he used that three-phase motor in his whatever vehicle name that was, that he got a vehicle and he made it into electric and he used that three-phase motor in there. And I believe that's where that three-phase motor had originally started from, with Tesla, okay? So nowadays, we're more advanced. We learned a lot more, and we are now dealing with three-phase in different ways. And one of the ways that caught my eye here, which now I understand it, maybe 5 years ago, 2 years ago, 3 years ago, 4 years ago, I didn't understand it. I just learned it. And in fact, I'm intrigued the fact that we could play along these lines here of conventionality and differentiality. And the reason I say those two things is because when you come over here, you got a stepper motor. It's a stepper motor ran as a three-phase. And I don't know how to describe this anymore, but these are all 36 poles, and you have 3 connections to them. The tail ends of all these are connected together, so you have a return path if you want it. You know what I mean? There's a return path. And if you were to magnetize this, you would need the return path for this to become magnetized, okay? For shits and giggles. And I don't want that to be off there, because that's right there is, we're going to do an experiment in about 10, 15 minutes. And this experiment, we're going to put power into this. And I'm going to show you guys what poles come out of this stepper motor washing machine. It's from a Samsung washing machine. Stepper motor, smart motor we'll call them. And the reason it's smart is because it can have a control from a control module, and it could deliver a north or a south pole on all these windings. And we're only dealing with one end of a core. So with these configurations here, what you have is, let's just say that it's 1, 2, 3, start over again. 1, 2, 3, start over again. 1, 2, 3, start over again. So you just have going around this whole wheel, and you have 3 times 12, 36 poles. Now remember, whatever pole comes out of here when we go to fire it up, I want you guys to leave your guesses, because this blew my freaking mind. Why did it blow my mind? Because what I thought the poles would be here was not the case. And after I started thinking about the control inverter, the AC frequency control inverter, I realized why it's set up like this. And this is a 12-inch bigger version of what we're dealing with here. Because this is 9 poles right here, okay? And what I did was I found where they were all connected. And it wasn't obvious. They had that thing tucked away. All the coils are mounted to this back plate, and here's your rotor with a shaft on it. So I had to find a path of return to make this, what you see here, happen, okay? The run-ins 65, 65, 65 watts, plus these little guys on top of here. And you can see that something special is happening because the torque of how this motor is designed as a motor, not a generator, has a lot of torque. But the way it's wired and the way the magnetism is not abiding by Lenz's law attracts me spectacularly. So I just have to say one thing here, that we're going to move over to this section here, and there's a reason why we're coming over here. These are the hubs, okay? These are the rotor, the rotor. And you got a rotor over there. But this rotor here is the one we're going to be working on, and it needs a compass. Like this busy table, guys? Yeah, those stepper motors, they're a lot to deal with. But one thing great about these the stepper motors, the controllers are very versatile, and you have different controls on the whole thing. Single phase, triple phase. You can have your current adjusted. You can stop it, reverse it. And this is why we're going to get into this, because here's your compass, okay, guys? And you can see on here, these are big fat chubbies of magnets. On this rotor, you can see they're not big fat chubbies. They're smooth and they're kind of pretty tame looking. These right here look like magnets on steroids. And surprisingly, you got to turn. You got to turn it vertically, but you can see that they are all north. You guys arguing? Oh, where's Lulu? All right, I just had to check on things. Sorry, guys. All right, so here we go. So listen, so back to this. So on here, I can put this down. And let me see if this compass, I whacked the compass out. When you put the compass near magnets, it shows the wrong poles. So if this shows south in here, what's really going on, it should be north. So it's showing south, but guess what? These are really north. These are all north facing. Every one of these inside this rotor is north facing, okay? I'll have to run a magnet on here. And actually, if you guys watch this, we'll do it together. Pretty cool stuff. So right here, here's the compass. Compass is not reading true north. North is that way. Well, it is now. So just run the magnet by the compass, and there's the true north running that way. So what I want to do now is see if it shows up. It should be north. Showing south. Nah, it's backwards. But anyway, so these are all north. And fascinating is that when you fire these up, what do you think these are going to be? Well, let's go ahead and let's connect the negative to my DC power supply. Let's go ahead and turn on my DC power supply. I'm going to go ahead and put it up to 24 volts, okay? And what we're going to do now is we have it already activated. What I need is the compass, which I just put somewhere. Hey, when that happens, there's a compass. All right, so I got this connected on the second one. So That means this one here should be reading the north. Okay? And then this one nothing, and then this one again, north. So what you have is, if you're going to use this as a generator, what's great about this, the fascinating thing that I'm realizing is that this becomes different than your normal motors that are built. All your motors are built with a north and a south. Now, I'm going to do a demonstration right now. I'm going to show you what I mean, okay? Now, we're going to watch this motor turn, okay? I'm going to take this neodymium magnet, and I'm going to hold it up near it. And what I want to demonstrate is Lenz's law, where this magnet is going to slow down that wheel. And why is it slowing it down? Because it's drawing from it. And when you put a load on this, it does the same thing. And there's half of your Lenz law. But what I want you guys to understand is because you're dealing with the south and the north, it becomes dragged down. With these stepper motors, when you fire up the inside coil and the outside are already negative facing in, and the inside coils are negative facing out, what you have is a push instead of a pull. Most motors are pulls. And what the pull does, it pulls in and allows Lenz law to be in its place. And you don't want the pull to be in there, because the more of a pull you put on it, the more stress it's going to put in the system. So you want to treat your, we want to run our house on a generator that has negative against negative. And I believe this is where Ed Lee Scallon comes in, and he always talks about it. Everybody's all excited about the positive, but it ain't the positive. Positive just gives a result. It's the negative that does the pure grounding, the base. And here it comes back to here is where what makes sense to me is that this motor, this little guy and this big guy right here are running the same way. And this is just a mini version. Let's go ahead and start this up and look at the drag. You can see what happens. I'm going to go ahead and just throw up. Let's just say this is a south pole, and we're going to start it. We'll go middle with it, low, okay? And now listen. It's doing the same thing that it does when you put a load on it. So what you're doing is must be increasing the magnetic field on one side. The side that's not turning, okay? So that would be the side that's not turning is the stator. So you're creating a bigger magnetic field on the stator side. So what makes sense here is that you would have a negative on a negative, not a positive with a negative, because this is why I believe the difference is. So let's step back right here, and let's fire this son of a bitch up, because I'm going to bring you close so you know exactly what you're looking at here. You guys ready? So you can see exactly what you're looking at, how it's running, okay? This Dremel is plugged into this blue amp meter, okay? I can switch it from amps to watts. Now, it's going to get loud, so what I want you to guys notice first is the amp pull, and then the draw of amps that goes along with this, okay? And as this starts, we start to put a load on, I want you to look at the numbers of the blue, what's going into the Dremel. And then I want you to look at the green meter, which is connected going into one leg of the three-phase, okay? So what I did was I tapped the back of this little motor where all three are connected, and we're coming out of that as a return path. So there's all three, and all three lights are connected to one side. right here is where the, let me get you zoomed in there. Okay, guys, right there is where the 3 wires are coming out, very thin. So I put my little breadboard connections in there, and I got 1, 2, 3 coming out. Off of the first one, which is this light, let me go back down, which is this light. Off the first one on that left side on this one, it does have the voltmeter in amps running. One leg goes to here, and the other leg goes to the start of the black side, the black part of the voltmeter, and then coming out of the red part of the voltmeter, we're going directly to the power source where it's coming from. So on one leg, you can see the amperage, okay? And this is going to be pretty cool. Yeah, I'll try to talk over if I can, but what we're going to do is we're going to put one on, and I want you to notice, everybody, it's all about sound. And then the reason I'm doing this video tonight, because these all things make sense, okay? And why do we have to be stuck with what we have? And if you look at what I've learned recently with this 3-phase stepper motor, is that it's negative on negative. So there is no attraction. Once you get rid of the traction, you get rid of Lenz's law. Makes sense? Yes, and it does work. So we're going to prove it here by, we know that this is 65, 65, 65 watts. Yeah. Be right there, sweetheart. And all right, start eating. So so when you put them together, you got 60, 120, 180, 195 in watts. And then these little guys here are 4.8 watts. And what I did with here, I put a resistor up here. And the resistor is because if I turn these off, the power goes that way, and it blows these guys out. These are only like 12 volts, maybe 13, 14 volts they can handle. They can't handle anything other than it blow them out left and right. But obviously what I did is I couldn't get all this to work right away. And I figured, what if I calm it down and smooth it out? And what smoothed it out was putting a capacitor in line. So on the positive side, as it comes out of each one of these are a phase. So we got 3 times what this produces. So as it comes out of the phase, it goes in one leg of the capacitor, out the other leg. So I'm just going through the capacitors that way. Okay, guys? Let's go ahead and let's start this up. And hopefully you'll be able to hear me as I talk. You ready? That's low. Nothing going on. Now we're going to go ahead, and you can see on the meter, nothing going on. You can see that we're at amps here. So we're at 1.1 amps, and right now we're at 134 to 35 watts. And that's to run the Dremel with no load, okay? Let's go ahead and turn it up faster. All right, nothing going on. Let's put a load on. So that's the one hooked up, and right now we're pulling a good, it says 18, 19, 17, and what I have to do is calm it down by putting another one on there, another load. Oh, I had a thing fall off. Hope I don't get shocked from this. Some good power coming out of here. Oh, hell yeah, I can feel it. All right, there we go. 2 is a load. 3 is a load. So we got 3 on right now. I want you to listen to the sound. Right now it says we're running 14 to 15, 16 amps. I don't know, that's kind of high. And we're still pulling 1.1 amps. We're at the same 134, 135 watts. And let's go ahead and start moving around. want to get them amps to go down. I think I burn out some lights. All right, let's go with sound, okay? Uh-oh. Oh, Houston. That ain't fixable right now, guys. So anyway, let's just start off with saying, great experiment. I have dinner to go to. And hopefully this was exciting enough, because it was exciting to show you guys. But the negative on negative with these motors is there's something special about that, which with Lenz's law, it definitely affects it for some reason. So you guys, peace out. Love you all. Talk to you all, my brothers. Leave your comments. Love the comments.